see the next similar sum. If cot inverse x plus cot inverse y plus cot inverse z is pi by 2, then prove that x plus y plus z is equal to x, y, z. So here again we take it like that. Suppose cot inverse x is alpha, cot inverse y is beta, and cot inverse z is equal to gamma, where alpha, beta, gamma should belongs to open interval 0 to pi. So the condition is satisfied. So inverse will become cot alpha is x, cot beta is y, and cot gamma is z. You have to even know that cot means what? 1 upon 10. So 1 upon 10 alpha is x. So therefore 10 alpha is what? 1 upon x can be seen. Similar way, 10 beta will be what? 1 upon y. And 10 gamma is what? 1 upon z can be seen. Now we keep the value. Here you have the first result, cot inverse x plus cot inverse y plus cot inverse z is equal to pi by 2. Means alpha plus beta plus gamma is equal to pi by 2. We keep only the value of cot inverse x is alpha, cot inverse y is beta, and cot inverse z is gamma. Alpha plus beta, and I say is equal to pi by 2 minus gamma. We take both the side 10, and it will be like this. 10 alpha plus beta is equal to 10 pi by 2 minus. We apply the rule, then it will be like this. Say 10 alpha plus 10 beta upon 1 minus 10 alpha. Now this say 10 pi by 2 minus gamma becomes what? Cot gamma. That also can I say 1 upon 10. If I cross multiply, so this 10 gamma we have to multiply to this numerator, and this denominator we take that side. So it will be like this. Therefore 10 alpha, 10 gamma plus 10 beta, 10 gamma is equal to 1 minus 10 alpha. So the final result will be 10 alpha, 10 beta plus 10 beta, 10 gamma plus 10 gamma, 10 alpha is equal to. We keep the value of 10 alpha. 1 is what? 1 upon x. So 1 upon x into 1 upon y. Like 1 upon y into 1 upon z plus 1 upon z into 1 upon x is 1. We take LCM, then it will be what? Z plus x plus y upon x, y, z. So therefore, denominator that take that side, so x plus y plus z is 1. We take the denominator that side, so it becomes what? X plus y plus z is equal to x, y, z. That's it. See here, the next sum is a quite similar only. If a cot inverse x plus cot inverse y plus cot inverse z is pi, last time that was pi by 2, this time is pi, then prove that xy plus yz plus zx is pi. We just move on a similar way. Cot inverse x is supposed to be alpha, likewise beta, and likewise gamma. So cot alpha is x, cot beta is y, and cot gamma is z. So convert cot in 10, so 10 alpha becomes 1 upon x. 10 beta is 1 upon y, and 10 gamma is 1 upon z. Now we just take it, the original question, cot inverse x plus cot inverse y plus cot inverse z is so alpha plus beta plus gamma becomes pi. So alpha plus beta is what? Pi minus gamma. Both the side we take a 10. So here we apply the rule 10 alpha plus 10 beta minus upon 1 minus 10 alpha. But this time pi minus gamma will be what become? It becomes minus 10. Because second quadrant 10 negative. We take denominator that side. So it is what? 10 alpha plus 10 beta. This minus 10 gamma we multiply. So minus 10 gamma plus 10 alpha, 10 beta. This 10 gamma we take the left hand side. So 10 alpha plus 10 beta plus 10 gamma is equal to 10 alpha, 10 beta. You can see tan alpha is nothing but 1 upon x. Beta is 1 upon y. So we can say 1 upon x plus 1 upon y plus 1 upon z is 1 upon x into y into z. Because they are in a product form. If I take the LCM, then it will be like this: yz plus lz plus xy. Understand? That's it. Okay, now see this sum is little bit lengthy. It's quite similar. Tan inverse yz upon xr plus tan inverse zx upon yr plus tan inverse xy upon zr is pi by 2. We have to prove x square plus y square plus z square equal to r square. Starting is similar one. Supposed to be tan inverse yz upon xr is alpha. Tan inverse zx upon yr is equal to beta, and tan inverse xy upon zr is gamma, where alpha, beta and gamma belongs to open interval minus r. Okay, so the inverse is possible, so therefore can I say tan alpha is yz upon x, tan beta is zx upon y, and tan gamma is xy upon z. Is that clear? Now we keep the equation this, but this is nothing but alpha, so I just write directly alpha plus beta plus gamma is what pi by 2. पूरा क्वेश्चन मैंने कर दिया. We take gamma that side, so alpha plus beta is pi by 2 minus. We take 10 both this side, so 10 alpha plus beta is 10 pi by 2 minus. We prove the result. 10 alpha plus beta is nothing but 10 alpha plus 10 beta upon 1 minus 10 alpha is equal to what we can see. So say pi by 2 minus, so it becomes 1 upon sorry, it becomes cot gamma. Pi by 2, so the function will change. And that cot gamma we can also express as a 1 upon 10. If we multiply, simple cross multiplication, 10 gamma to this 2, so it is 10 alpha, 10 gamma, plus 10 beta to 10 gamma is equal to 1 minus 10 alpha. That minus 10 alpha, 10 beta we take this side, so it is like that, 10 alpha, 10 beta, plus 10 beta, 10 gamma, plus 10 gamma, 10 alpha. Now we keep the value of 10 alpha, that is yz upon x, into 10 beta, zx upon y, plus 10 beta, zx upon y, 10 alpha, 10 gamma, xy upon z, plus 10 gamma, xy upon z, into 10 alpha, yz upon. You can see this, x will be cancelled, y will be cancelled, y will be cancelled, z will be cancelled, z will be cancelled, x will be cancelled. So what will happen? Z into z, z square upon r square, plus x square upon r square, plus y square. So therefore it will be x square plus y square plus z square. The common denominator r square we take in opposite side. So this, that's it. So this is another similar sum. If tan inverse root AR upon BC plus tan inverse root BR upon AC plus tan inverse root CR upon AB is pi, then prove that A plus B plus C is pi. Here also we prove some result and we substitute the value. First of all, let tan inverse root AR upon BC is x, tan inverse root BR upon AC is y, and tan inverse root CR upon AB is z. where x and y and z belongs to open interval minus 1. Okay. So the inverse is possible. So we can say tan alpha is root AR upon BC. Like this. And y is root BR upon EC. Like this. And z is root CR upon E. Okay. We keep the value. This tan inverse is what? Nothing but x. So x plus y plus z is equal to take z that side. So x plus y is equal to pi minus 7. We take about the side 10. So tan of x plus y is tan of pi minus 7. This is pi. Now we apply the rule. So it is tan x plus tan y upon 1 minus tan x is equal to pi minus means what? Second cardinal. Tan is negative, so we can say minus tan. We take it denominator opposite side, we multiply. So it is what? Therefore tan x plus tan y is equal to minus tan z plus tan x tan y. I hope you clear. This minus tan z, we have to multiply to this denominator, which we take that side. Okay. This minus tan z, we take this side. So tan x plus tan y plus tan z is equal to tan x tan y tan z. We substitute the value. Now this is important part. Tan x, x not alpha. Tan x is root AR upon BC plus root tan y BR upon AC plus root CR upon AB is equal to, so all are in a multiplication form, AR upon BC into BR upon AC into CR upon. You can see in the multiplication form this A cancel, this B cancel, and this C cancel. And here, what we do here, this BC, AC, and AB. So if I take the LCM, then it should be what? Root ABC. See, from the numerator R, that R we take common, means root R common. Now here, we multiply root A up. Root A into root A means A square. Root A square becomes what? A. Same thing here, we multiply B. So B square, root B square is B. Like this. Is equal to, you can see this, R into R square means R, this root R. Upon what? Root A. This calculation is important. This root R upon ABC cancel. So you will get A plus B plus C is equal to R. That's it. Yeah. Let's see the another differential sum. If a cos inverse x upon A plus cos inverse y upon B is theta, then prove that x square upon A square minus 2xy upon AB cos theta plus y square upon B square is equal to sin square. See, first we take cos inverse x upon A is alpha and cos inverse y upon B is beta. Okay, where alpha and beta belongs to closed interval 0. Clear? So the inverse is possible. So cos alpha is what? X upon A. And cos beta is what? Now your sum will be what? Here you have cos inverse x upon A plus cos inverse y upon B. Cos inverse x upon A is alpha plus beta. And I say it's equal to theta. Up to this clear. Now what we do the next? Let's see. So can I say, if I apply the cos rule here, then it will be what? Cos of alpha plus beta is equal to cos theta. Understand? The rule for cos alpha plus beta is cos alpha cos beta minus sin alpha sin beta is equal to say cos theta. See, we want also sin alpha sin beta. You have a cos alpha. You know that sin square alpha is what? 1 minus cos square alpha. So sin alpha becomes what? So say root of 1 minus cos square alpha is x square upon a square. So in short, sin square alpha is what? A square minus x square upon a can be expressed. Similar way, sin beta is what? So now you know that 1 minus cos square beta. So it should be root of 1 minus y square upon b square. So can I say root of b square minus y square upon b? Okay. Now this all the four values we keep here. Then cos alpha is x upon a, cos beta is y upon a, minus sin alpha is root of a square minus x square upon b into root of b square minus y square is equal to cos theta. We take LCM. So AB we take that side. So xy minus root a square minus x square root b square minus x is equal to, can I say, AB cos theta. I am taking AB cos theta this side and this opposite side negative term. So it is xy minus AB cos theta is equal to root of a square minus x square root of b square. If I square, then it is what? xy minus ab cos theta whole square is. Now the square root is cancelled, so it is a square minus x square b square minus b square. Here we use as a minus b whole square, a square minus b square, so a square minus 2ab plus b square, and that one we expand. So it is say x square y square minus 2xyab cos theta plus a square b square cos square is equal to, so this a square b square minus a square y square minus b square x square plus x square. Is that clear? You can see this x square y square is cancelled both the sides. Understood? Now, what will be the cancel thing? Another one? Nothing. We keep it as it is. See, this negative term, we take it this side, so it will be a positive. B square x square plus a square y square. This two I am taking this side. Minus 2xyab cos theta is equal to, I am taking this term opposite side. So a square b square minus a square b square cos square. Is that clear? Look, here a square b square common. So remaining is 1 minus cos square. That will become sin square theta. And if I divide this whole term with a square b square, so I am writing here this, it's lengthy, b square x square upon a square b square plus a square y square upon a square b square minus 2xy ab cos theta upon a square b square is equal to say sin square theta, because this 1 minus cos square theta is sin square theta. So this AB will be cancelled, so it is like that, x square upon a square. At write this negative term first. So minus 2xy upon AB cos theta plus y square upon b square is equal to 6. It's lengthy but easy. Understand?